All right, we're going to talk a little bit about some application problems. And these kind of problems are what I think of as sort of pure number problems. Now, I've talked a little bit about translation in one of my other videos, but this one is where we've got a lot of information, but it's just going to be a matter of organizing it. So in this example here, I've got Cody is twice as old as Evan. 5 years from now, or five, sorry, 5 years ago, the sum of their age was 11. Find the age of each boy now. So with this, it's just a matter of organizing the data. And I've got two boys. With this is going to be, I think, most helpful to make a table and fill it in. So I've got two boys. I'm going to just say we've got Cody and we've got Evan. And we know a couple things about now, and we know some things about 5 years ago. So right now, we don't know how old either of these boys are, except I know that Cody is twice as old as Evan. So if I say Evan is, how about I just call Evan X years old? Right now, I know that he is twice as old. He's going to be double that. Now, 5 years ago, this is interesting because at this point, we don't know anything about this except that it's 5 years ago. Well, 5 years ago, Evan is just going to be this same amount of age, but I'm going to subtract that 5 from that. Same thing with Cody. I'm going to take Cody's age, and I'm going to subtract 5. Now, this is another piece where I say that the sum of their age was 11. So I know that if I take both of their ages, if I take that 2x minus 5, so that's how old Cody is, or was, and if I take Evan's age, x minus 5, I know that that sum is equal to 11. Now I have enough information to solve for their ages. I'm going to add these things together, and it looks like I've got 2x and x, so that's just going to be 3x. Minus 5 plus a minus 5 is going to be minus a 10 is equal to 11. I'm going to go ahead and add 10 to both sides of my equation. So I'll end up with 3x is equal to 21, and then I'll divide both sides by 3. So I've got x is equal to 7. Now, I haven't answered my question yet. So because I know that x is equal to 7, I can now say, oh, Evan is 7. Evan is 7 years old. So there is my first answer. And Cody is twice as old. So this is, of course, 2x. So I can say that Cody is 14 years old. And we found the age of both of our boys here. Now I can do, the funny thing is we can do all sorts of things with this. We could have sums here, do other things. I have another example. It's very similar to this first one. This time I've got Jack and Lacey. And once again, Jack is 2 times as old as Lacey. Well, let's set up a table of values. I've got Jack and I've got Lacey. And I know some things about now. So now he is twice as old as Lacey is right now. So this is our now. And I've got 9 years ago. And I could just as easily have 9 years from now, or I could have or I could have other things. If it were 9 years from now, instead of having a -9, it would be a +9, but this is -9s. The sum of their ages, so 9 years ago, the sum of our ages, so sum means we're going to add these things, so I'm going to have this 2x minus 9 plus x minus 9, and the sum of their ages is 21. All right, let's go ahead and do this. 2x plus x is going to be 3x, minus 9 plus minus 9 is minus 18. I'll go ahead and add 18 to both sides. So I've got 3x is equal to 39, and I'll divide both sides by 3. So I've got x is equal to 13, which means Lacey's age is x, so I can say that Lacey is 13 years old. I can also say that since Jack is 2 times Lacey's age, that right now Jack is 26 years old. And there we have it. Alrighty, that's all I've got for now, and I hope to see you in the next video.